Hello everyone. In this video, we are going to figure out the IUPAC names of these four structures. Let's do this one by one. Our functional group here is aldehyde, and therefore this can be named as methanol. And then we have a benzene ring, so that can be called as phenyl. And then we have a methyl substituent. So let's do the numbering from here. 1, 2, 3, 4, 5, 6. So at 4 position we have a methyl group, 4 methyl phenyl methanol, because it's an aldehyde. Now this is the systematic IUPAC name. We can also have one more name for this, because this unit as a whole we call it as benzaldehyde, and therefore the preferred IUPAC name for this molecule is 4-methyl benzaldehyde. So this is the preferred IUPAC name. This one is, the other name is systematic. Let's go to the next example. In this example, our functional group is ketone, and we also have one alkene, and therefore let's do the numbering from here. 1, 2, 3, 4, and then one of the methyl groups will be treated as a substituent and another one becomes part of the chain. Let's rewrite the structure in this way. So 1, 2, 3, 4, 5. So at 2 position we have the ketone, and 3 position we have the double bond alkene, and then at 4 position we have the methyl group. Our parent chain has 5 carbon atoms, so it is pentene. So 4 methyl, because at 4 position we have the methyl group. Pent, 3 ene, 2 one, because at 2 position we have the ketone. That's the correct IUPAC name for this structure. Let's go to the next one. We once again have a ketone, we once again have a alkene, but the structure is given in a specific way, and let's do the numbering first. 1, 2, 3, 4, 5, 6, 7. In this example, our parent chain has 7 carbon atoms, and around the carbon-carbon double bond we could see that 4 different substituents are there. Yeah, here we have a hydrogen, because we don't show the hydrogen atom in the bond line notation. So therefore we have to follow the EZ naming convention here, because we have 4 different groups attached to it. We cannot follow the cis trans naming convention. Let's do this. So this gets the low priority because hydrogen, and here we have a carbon atom that gets the high priority on this side of the double bond, and then on that side of the double bond we have a carbon here, and then 3 hydrogens, and here we have a carbon, 2 hydrogens, and then we have a carbon. So because it is carbon-carbon bond, and here carbon hydrogen, 3 hydrogens, here it is carbon, 2 hydrogens, and then carbon, this gets the high priority as per the EZ naming convention, because if we just take into the first carbon into account, they are same, but then we have to go for the next position if they are same. So this gets the low priority. So our high priorities are on the opposite side, and therefore E. Yeah, our high priorities are on the opposite side of the double bond, and therefore it should be E. So 4,6 dimethyl, because we have methyl substituents at 4 position as well as at 6 position. So 4,6 dimethyl hept, and then in bracket we should mention the 3E, because at 3 position the double bond is there, and then ene, and then 2 one, because we have the ketone. That's the correct IUPAC name for this molecule. So we have an hydroxyl functional group here, we have an aldehyde here, So in terms of priorities, we know that aldehyde gets the more priority than the alcohol, and therefore aldehyde is our functional group now, not the OH. So this is the functional group, and therefore we start the numbering from there 1, 2, and this carbon is 3, and then one of the methyl groups will be 4. Another one will be treated as substituent. So let's rewrite the structure. So if we rewrite the structure, this is H3C, and then you have the OH, and then you have CH2, and then C double bond OH. So do the numbering once again 1, 2, 3, 4, and therefore the correct IUPAC name is 3-hydroxy and then 3-methyl, because we are following the alphabetical order. H comes before M. So 3-hydroxy first, not 3-methyl first. 3-hydroxy, 3-methyl, 4 carbons are there in our parent chain, and we have an aldehyde, and therefore butanol. That's the correct IUPAC name for this molecule.